And we're going to move on to our 11th hour of programming in this 24-hour PEI Share-a-thon of Science and Education. And I'm Betty Trummel, the host for the next 3 hours. I'm going to share my screen and start the PEI trailer that I'd like you all to see before we launch into our next program.
Of some people from the Antarctic Research Center in Victoria University in Wellington.
Okay, so welcome to our next session. We're going to go from the Arctic now back to the Antarctic. So we're switching poles. I'd like to play our trailer that gives you an idea, a little bit more of an idea of what PEI is all about.
Yeah. Yep.
Then I'll start. Yeah.
And I have to be here at 2 o'clock.
Give it 1 minute here to buffer. All right.
Polar Educators International is connecting educators, polar researchers, and communities for a better understanding of polar knowledge. Earth's polar regions are remote, beautiful, and challenging places, and they have a profound influence on every one of us. We know these vast amounts of snow, forming ice sheets, sea ice, and glaciers, together with massive currents of cold water, contribute dramatically to the climate and ecosystems of our world, systems which in turn drive the health of our local environments and communities. Research shows dramatic change in the Antarctic, in our mountainous regions, and particularly in the Arctic, home to over 4 million people, which is changing faster than anywhere else on Earth. Scientists are confirming that human activity is playing a significant role in these systems, increasing the planet's surface temperature in ways that cannot be balanced out by natural processes. It is clear the urgency to engage the next generation in polar research and to rise to the challenges that a changing climate will bring has never been greater. United in our passion for sharing the importance and value of the polar regions, educators and researchers from around the world have formed PEI, an essential global network developing polar knowledge to engage a global audience facing climate change. We are collaborating to strengthen this community, building resources and relationships, and helping local audiences connect polar research to their everyday lives. Polar Educators International amplifies the voices of all those dedicated to understanding and protecting our extraordinary polar regions, and all Earth's inhabitants, for generations to come. Join us.
Okay, would like to just briefly mention that we're going to be having our conference in Iceland in April of 2020, excuse me. And this will be a great opportunity to be with Polar Educators International, doing workshops and professional education development. And we're doing a lot of online activities leading up to this workshop. So check out the website and try to join us in some of those activities. Also, make sure you add comments or ask questions on our Slack channel, either during the event or after our event today. And also you can post comments and questions in the box as well. So let me share the two speakers we're going to have this hour. Our first speaker will be Dr. Tim Naish. He's a professor of earth sciences and former director of the Antarctic Research Center at Victoria University in Wellington, New Zealand. So we'll hear from Tim first. And then we will hear from Dr. Rob McKay, who's the current director of the Antarctic Research Center at Victoria University in Wellington, New Zealand. So we'll get started with Tim first.
Okay, I want to introduce Dr. Tim Naish, who's a professor in earth sciences and at the Antarctic Research Center at Victoria University in Wellington, New Zealand. And he's going to share with us his experiences in Antarctic science and research. Welcome, Tim. It's good to see you.
Thank you, Betty. It's great to see you too. I'm at home. We are under COVID lockdown.
As many people are. So Tim and I have known each other for quite some time, over 20 years, first working together in Antarctica in 1998 on the Cape Roberts project. I wanted you to talk about how you got into Antarctic science and research, Tim.
Good, great question. I didn't take perhaps the most traditional path. So Cape Roberts project, Betty, where I met you, was my first experience of Antarctica. So I was 30 years old. And that's actually quite old to have started in Antarctica. A lot of my colleagues, they did their PhDs down there. They were down there as students and have always worked in Antarctica. Where I did my PhD, I was working in New Zealand, and I was interested in sea level change and how global sea level has gone up and down in the past. And I had opportunities, actually. I had opportunities during my PhD, or even before my PhD, to go to Antarctica. But I thought, it's so far away and it's cold and, it's remote. What if I got halfway through or got back to New Zealand and realised I needed more samples? It'd be very hard to go back. So, I was, even though I'm a bit of an adventurer at heart and I love climbing mountains and tramping and that sort of thing, I didn't want to go there for science. And so I did this PhD on sea level change. And then I got to know some of these Antarctic sort of characters, some of them legends, people like Professor Peter Barrett here in New Zealand. And he was leading the Cape Roberts project. And it turned out that one of the British scientists, so this was an international project with scientists from all around the world, it turned out that one of the British scientists, Mike Hambry, had to pull out. And so I was sort of a ring-in at the last minute as a stand-in Brit. I was Mike Hambry, but I was Tim Naish. But yeah, they joked about the fact that I didn't look at all like Mike Hambry, but that's okay. So that's how I got in, and I thought, well, goodness me, what an opportunity! I'm big international project, drilling through the sediment layers next to the Antarctic ice sheet to understand how that ice sheet had grown and changed in the past. What an opportunity. So, it's a bit of a late starter, but since that first opportunity, I've had 14 seasons down there and I've never looked back. I think we're answering some of the biggest questions facing climate science down there today, and it keeps me going. But also, Betty, as you know, you also fall in love with the place. You get the bug. You want to go back. And it's partly the culture, the people, the environment, and what you're doing down there that brings you back every year. So it's a mixture of adventure for me and science and discovery as well.
Tell me a little bit about the Antarctic Research Center at Victoria University.
Yeah, well, I used to be the director of the Antarctic Research Center. I took over in 2008. I'd just been on a sabbatical, a study leave in the United States, actually, where I'd been at Northern Illinois University writing up some results from the Andrel project, which was another big drilling project I was involved in the leadership of. And that's another time you and my path crossed, Betty. We stayed with you and Chris in your home in Crystal Lake. I was on sabbatical, which was great times. The kids were young, and we got a lot of good science done with a good colleague, Ross Powell. But the Antarctic Research Centre really is a wonderful environment. When I joined it, which is more than 10 years ago now, Peter Barrett, who I mentioned before, had developed it over several decades, and he worked very closely with an engineer, scientist, engineer, just an all-round sort of practical person when it came to drilling. And so Alex Pine is this engineer, and Alex Pine and Peter Barrett developed drilling technology to be able to drill the sediment records, the geologic information that we get from around Antarctica. So when I joined, it was small. It was Peter, it was Alex, there was Tamsin, and there were a few students. And we were up against it. We didn't have a lot of funding, and the university, for some crazy reason, decided that they were going to shut the Antarctic Research Centre down. In fact, that was a bit before I joined, and so I'd been involved in helping rebuild it with Peter and winning some funding. And it became a roaring success. We got some big grants in, research grants. Then we had the Andrew project, which, again, you were involved in that too, Betty, as one of the teachers, one of the educators. And so that really happened. The build-up was most of the 2000s. We drilled in 2006 and then in 2007 again. And then I became director in 2008. So the Antarctic Research Centre was really in its growth period. So at that time, we employed a lot of really talented young people, early career scientists who were interested in the history of Antarctica, the deep geological history, were interested in computer models of how climate and ice sheets work, were glaciologists. And, you know, we got these young people on board, and they were very successful researchers, and they brought in money. And the whole thing snowballed. And we before we knew it, we were, right today, we're 20-something staff, and we're about 25 graduate students, maybe more, I lose count. And we're a very multidisciplinary group. So it's an absolute privilege as a researcher to be able to go to the office next door and knock on Nick Golledge's door, who's one of the world's leading ice sheet modelers, and have a chat to Nick about ice sheet modeling. Then I can go down the room and down the hall, and I can talk to one of our older staff members, Professor Lionel Carter, who's a marine geologist and an expert on how oceans interact, move heat around, and interact with ice sheets. And so we're so lucky. We've got one of the world's leading research groups now, where we have critical mass. We have a mixture of experience and age, but also that enthusiasm and dynamics that come from younger people, from students, from postdoctoral fellows and early career researchers. So
it's a great mix. And I've watched this grow in the last 20 some years since the Cape Roberts project. I've seen this growth and this change, and it's really exciting. And I think the different age levels and the different experience levels and types of experience really add to the whole Antarctic Research Center, your whole knowledge base.
Absolutely. And it's such a satisfying thing as an older leader of the group to see the young ones come through, develop, and then take over. So now Rob McKay is running the Antarctic Research Centre. He's soon to become a professor. He is in his 40s. He was my first PhD student on the Andrew project.
Amazing.
It's amazing, isn't it? And we've got there's many examples. There's Nancy Bertler with the Ice Core Research Program, who are now just leading the way. So you feel this great sense of satisfaction that, you know, we've grown something that's of benefit to young people, but also making a difference with our international partners and friends and colleagues.
Absolutely.
And, you know, we're looking at this whole problem of climate change now, which when I first began, you know, there was, we knew about it, but it wasn't such a big issue. And so it's been good timing and an absolute privilege to have been involved with this group and help build this group of people.
Now, one of the things, I mean, Polar Educators International, who's sponsoring the Share-a-thon event, we try to link scientists and educators together and try to provide resources for people around the world. And you and I have worked together, as you being the scientist, me being the educator. How do you see education fitting into all of the research that you're you guys are doing. And how did that work in terms of Andrew? Because you were one of the co-chief scientists that I worked with. And so how did you see the contributions of the educators who were part of the ARISE program, part of our education outreach program for Andrew?
Yeah. Well, as you say, Betty, the educators were a very significant part of our whole program, multi-million-dollar program. And at a very early stage, we decided we were not going to do this work unless there was a legacy, an ability for what we were learning and what we do down there as scientists to be able to be shared with young people through education and giving them perhaps some opportunities, not only through learning, but, through the experience to do these sort of things. So it was never it was always if we do this, we embed the educators from the beginning, and you were part of the team. I have to admit, it was newish to me to work so closely with a group of educators from all around the world, and there was a little bit of, what are these crazy teachers going to be like?
Yeah, crazy.
What questions? What are they going to make us do? And all these sort of things. And how is it?
We had the same questions about the crazy scientists and how were we going to take what you guys were doing and how we were going to interpret that, learn from it, interpret it, and then get that out to not just students, but the world. So, it was a lot of apprehension on our end, not so much for me because I had already done this with Cape Roberts 7 years prior to that. But I think it's always this kind of question mark. What's it going to be like to work with the scientists? Are they going to be open to us being right by their side, learning their work, helping them with their work? And then are they going to help us explain that to everybody that we want to reach with our outreach?
Exactly. And I think to a certain extent it was a bit of jump on into the pool and let's see what happens. Yeah. But it's true, you and I had a previous experience together during the Cape Roberts project that I found very valuable, as well as another colleague of mine, Cliff Atkins, a New Zealand geologist. And that relationship goes right back to there, where when I was talking about this with my American colleagues, I was saying, if it works like the T program did, or I think we called it the T program.
It was TEA, but T, yeah.
Yeah. And if we get people like Betty, then we can't go wrong. It'll be fun, and she'll work us hard. But that's great. And I think some of the most rewarding parts of these projects are when we see the products and the opportunities young people get through the teachers, and to be involved with them, to come to your events years later, to come to your classroom, Betty, and meet your students, to do videos, to be involved in so many activities that people still talk about.
Yeah, they do still talk about it.
They do. The Andrew program, NSF, the National Science Foundation in the US, invested a lot of money in the Andrew program in the education and outreach side of things. And I think it's recognised as an absolute example of how you do it well. And the frustrating thing is, as budgets get tighter, we've been through a global financial crisis, now we have COVID, it's harder and harder to get the funding to do the education and outreach properly. So I look back at Andrew as setting a really high standard.
I think it set the bar really high. And I can tell you, from an educator's point of view, that students that I had back then and the students that I talk to all the time during presentations now are very interested in what's going on with the science. Many students have gone into science, into geology, or into science, especially many females, as a result of having the opportunity to see scientists in their classroom, to see the work of scientists, to communicate with scientists. And I think that it's made a huge impact. I really do.
Absolutely. And that's fantastic to hear, because that's really what it's all about, is inspiring the next generation.
Absolutely.
And the fact that the world's a wonderfully interesting place, and the fact that, it's theirs.
Yeah, it is theirs.
So, they've got to live in it, deal with it. It's up to them. And, we want them to take ownership and use science.
Well, I feel a lot better knowing that the some of the students that I taught have gone into science, very capable students. I'm like, okay, good. Whew, we've got good people going into science. So I think it's super important. So tell me about some of the things you're currently doing. Like, what's your current research focus?
Okay, well, it's not dissimilar. I mean, we're still exploring the history of the Antarctic ice sheet. I've found with time I've moved away from, the hands-on science, and I'm more into the science leadership at the international level. So I'm
policy.
Helping also coordinating science within international programs like the Scientific Committee on Antarctic Research, SCAR, and the World Climate Research Program. But also, as you mentioned that word policy, and more and more, I've been involved in communication and engagement of what we're learning about Antarctica and the climate system, how that matters in terms of the impacts we may experience as humans around the world with climate change. So, obviously one of the big uncertainties is what will happen to the Antarctic ice sheet as we continue to heat the atmosphere. And it's melting. And when it melts, it contributes to sea level rise. So, a lot of the work I'm doing now is helping us to better predict how fast the ice sheet will melt, how quickly sea level will rise, and what will be some of the impacts for places, well, for all of us, for anyone living on the coast, as I know you do, you live near the coast. I guess I want to do things that are a little bit more applied and immediate to some of the problems that we need science to help sort out.
Okay. What else? What other interests can you talk about in terms of other research going on at the ARC? You've mentioned Nancy Bertler and the ice core science. I know there have been a lot of different themes and projects going on.
Oh, for sure. And that's what makes the place so exciting. There's many big projects going on and quite small projects. One of the things we've done, as well as the geological drilling, is we drill ice cores. And so we've been drilling through the ice sheet. And the ice cores are amazing because they really can give us some really interesting information about the climate in the past that rocks can't. And the obvious one that you may have all heard about are the bubbles that get frozen into the ice. So when it snows, you get the snow accumulation, and then over time, after several years, that snow starts to compact and it traps bubbles of air. And so you can drill down through the Antarctic ice sheet several kilometres, and you can get a continuous history, a continuous record of how the Earth's atmosphere has changed. You can measure the carbon dioxide and the methane levels, the greenhouse gas levels, and then you can reconstruct the temperature and look at how climate has changed. So we never did this in New Zealand. We didn't have an ice core drilling program when I started at the Antarctic Research, when I got to know people at the Antarctic Research Centre. And then this young German lady appeared, a girl who was looking for a PhD, and she didn't want to do rocks. She wanted to do ice. And this is Nancy Bertler. Yeah. And she came to Peter Barrett and said, I'd like to do ice. And Peter said, we don't do ice. And how about rocks? And she said, no, I want to do ice. And he said, well, we'd have to, if we do that, Nancy, we'd have to build the infrastructure here in New Zealand. We'd have to have an ice core facility. We'd have to get drills. And so at the end of that Cape Roberts project, Cape Roberts 3, the third year of drilling, Nancy and Peter and the driller, whose name was Pat Cooper, and I think Warren Dickinson, went up onto a glacier behind Cape Roberts and started drilling ice. Not very successfully, I have to say. And that's what started it.
Isn't that crazy? Just something like that. Just, it's not random necessarily, but it wasn't something that was part of that project originally. Yeah. Something they're going to do after the project.
Exactly. And we thought, oh, this won't go anywhere. We're not ice drillers, we're rock drillers. What do we know? But Nancy not only got a PhD in ice coring climate science, she then developed all these international colleagues with the top ice core laboratories in the world, one at the University of Maine in the USA. She built a really strong relationship with the Alfred Wegener Institute and in Germany. And before we knew it, they were lending us drills. They were letting us use their laboratories to do the analysis of the air samples and the ice samples. And Nancy had created this ice core research laboratory and program in New Zealand at GNS Science in Lower Hutt. So when I was at GNS Science, my job was to raise several $1 million to build a freezer building so we could store all these ice cores. And the rest is really history. We got that across the line, and now, part of what we do is regularly go to Antarctica to drill ice cores to get those climate histories. We're a bit different than say some of the big projects you may have heard about, Betty, like Lake Vostok or Epica. These are, or Greenland even. These are big drilling projects that try and get the oldest, longest records from the centre of the ice sheets. They cost literally tens of millions of dollars and involve many nations. We do a similar thing, but at a smaller scale, and we're drilling near the coast. So we don't drill in the middle, we drill on the edge of the ice sheet, where we can understand something about the local climate because we're so close to the ocean. And so this has developed a real niche where Nancy's, she's quite well famous now, and her records don't go back as far, but they sort of tell us how the climate is changing, for example, in the Ross Sea, and how that might be different from how the climate has changed in the Antarctic Peninsula on the other side of Antarctica. So it's really interesting, and now we're able to get information from these ice cores, which, you've got every year as a layer. You can get yearly resolution, and then you can compare it to temperature records, and then you can take that information both back in time and extend the temperature records that we measure with instruments like at weather stations in Antarctica. We've been doing that for 50 years. And what we're realizing is our ice core records are incredibly accurate and similar to the temperature records. And we're able to then get much more information out of the ice cores as we go deeper and back further into, the 19th, 18th, 17th, 16th century. And then, of course, what we're also interested in is saying, well, trying to help everyone understand what will happen as the climate warms and how will these regions change. And so, the ice coring's been loads of fun.
Well, and I think it's inspiring to see how Nancy was determined she really wanted to study ice, not rocks, and she made it happen. And I think as a woman in science, it's cool to watch someone's path. And I think going back to when I first met you in 1998, I think about the Cape Roberts Project and how few women were involved with, down in Antarctica for that season, and how I've watched that, and you, I'm sure, have watched that change over the years to involve more and more females in science. I mean, what's that been like for you to watch that change? Because it's a big change.
Yeah, great observation, Betty. You're absolutely right. We were a bit of a man fest, to be honest. It was all men in Cape Roberts, and when we set up Andrew, some of the women who I knew, my women colleagues in Antarctic science, called it mandrill because they had so much men involved in it. We definitely were male dominated, and we all know that, particularly in research and geology and academia in general, but in the sciences, it has tended to be a bit male dominated. So you're absolutely right, that has changed. And if we look at Nancy, she is now the director of New Zealand's entire Antarctic research program. So she's now in charge. That's wonderful to see. Yeah.
Yeah, I think it's really been interesting for me during my teaching career to watch all these changes and to be a part of the Antarctic science with all of you.
Yeah.
Do you have any other insights or things you want to share with us?
Totally. I mean, I think I think it's important that we realised that we needed to become more diverse as a group, not only through youth at replacing some of us older ones, or the legacy that needs to be maintained, but also with more females involved in the research. So, one of the things I just would like to say is the next director after me really took that very, very seriously. And now the ARC, in terms of staff, is more dominated by women. So we're more than 50% women. And our students have always been fairly well represented in terms of male-female, about 50-50. Sometimes sort of 60-40 towards women. The frustrating thing for us in geology and Antarctic science is that didn't translate into the workforce. And so what we were seeing is obviously it was much tougher once you had a baby, and it was always easier just for the man to have their career keep going and the woman had to step out. And so there are lots of things we now have in place to try and accept that, acknowledge that. And I think that's one of the reasons we're starting to see quite a number of really talented, actually, researchers coming through who are now female.
Yeah. It's been a great thing to watch. Well, Tim, thank you so much for spending some time with me today and sharing your experiences, because I think it's valuable for people to hear about them. I know how much that this has impacted me and my career as an educator and working with scientists, and I think you have the chance to keep doing that long into the future. And I think I'm glad to see that education is still a part of what you do as a scientist. So, okay, I'm going to stop the recording.
Okay. We're going to go right into Rob's talk. As you mentioned before, he is the current director of the Antarctic Research Center at Victoria University in Wellington, New Zealand. And he'll give some of his perspectives on the current science and his path as a scientist.
Hi, I'd like to introduce Dr. Rob McKay, who's an associate professor and the director of the Antarctic Research Center at Victoria University in Wellington, New Zealand. Hi, Rob. Thanks for joining me today.
Kia ora, Betty. So thank you for inviting me. So I'm going to give a presentation on the history and evolution of our research centre that we have at Victoria University of Wellington in New Zealand. So I'm the director of Te Puna Pātiotia, the Antarctic Research Centre, and I've put our Maori name up front here, which are the Indigenous population in New Zealand. And this name is one that we're quite proud of, because it's something that actually connects us to the Antarctic environment quite closely. It's not a literal translation. It means that we are, the Pātiotia stands for to be frozen over. So obviously we're on the frozen continent. That's quite a literal translation there. But the Te Puna is the spring, that knowledge springs forth from this environment. And so that's the connection that we want to make, that we go to Antarctica not to learn about it, we go there to learn from it. So the spring is really important because it means that knowledge upwells and flows out of this environment to us. And also as a physical scientist, it's quite an interesting connection there, because you look at how the ice sheets behave and interact with the oceans around Antarctica. So you actually have that literal implication of upwelling waters coming onto the continent and helping actually to melt these ice sheets. We know today that the ice sheets are very sensitive to oceanic change, and that's a function of warm waters upwelling onto the continental shelves and eating away at the edges of these marine ice sheets. So that's just a little bit of sort of metaphorical context for what the ARC are. Our sort of mission statement is to understand what is the impact of Antarctica's environment on New Zealand as well as the global system. And the global systems includes people within that. So not just the Earth, but also society. So in that context, I thought it'd be really good just to start with a definition of where we've come from, always recognising in Maori terminology what our whakapapa is, our history. We really do view ourselves as a family here because we have 70 years of history. We had a first expedition in 1957 with Peter Webb and Barry McKay here in the top image in black and white. Peter Webb subsequently went on and had a very successful career in the United States at Ohio State. And Barry in Australia. And about 15 years later, after having an expedition every year, there was formally established the Antarctic Research Centre that was led by Peter Barrett, who is in the grey t-shirt here, and was my master's supervisor at Victoria University as well as my PhD supervisor. At that point in time, there was only a couple of people in the Antarctic Research Centre, very much focused on looking at the geological history of the continent. Peter's primary interest was looking at the Gondwanan history, so when the continent was connected to Australia and South Africa and New Zealand, and there were dinosaurs walking around. So very sort of big picture, tectonic, perhaps what you call an academic pursuit, just understanding how the Earth is working for the sake of understanding what the Earth is. But then Peter subsequently got very involved in understanding what the history of the ice sheets were. And in his time period as director, we could start seeing that actually these ice sheets hadn't been there permanently. They had come and gone through time quite dramatically. And we got interested in what were some of the environmental conditions that led to loss of these ice sheets in the geological past. So I came into the scene in the early 2000s, particularly mid-2000s, to do my PhD. This really started to take over, that we weren't just doing an academic pursuit, we were looking at something with quite strong societal implications. And subsequently, Tim Naish, who was also my PhD supervisor, did a big drilling project called the Angel Project that really emphasised that ice sheets can go in 2 to 3 degree warmer climates in present. And this really triggered a whole new area of research for us. We started investing in climate modellers to understand, can we recreate these past conditions in climate models and then project them forward in the future to see what might happen when we're raising CO2 over timescales of hundreds of years rather than millions of years. So 2019, we've sort of evolved into over 20 researchers in our department. 17 of them went to Antarctica in 2019. We had an expedition every single year up until that year. And last year, unfortunately, we had no researchers deployed to Antarctica due to COVID-19. We had a field season cancellation. So a blip in the record there, but I'm actually quite proud of that because we never slowed down over this time period. We've built such a diverse portfolio of research interests, particularly with this climate modelling connection, research in New Zealand, what are the impacts of Antarctica on New Zealand, that actually we have a strong enough research campaign that we can actually survive seasons without going down physically to the ice and still really produce societally relevant science that New Zealand taxpayers and even global taxpayers are helping to fund. This didn't mean that we also had no polar expeditions. We actually had one researcher go to the North Pole. She was scheduled to go right when border shutdowns were occurring. So she would have been stuck on this icebreaker almost for 6 months. This is the Polarstern, a German icebreaker, European expedition. They froze the icebreaker into the sea ice in the North Pole for over a year. And scientists flew on for 2-month stints to research on there. Russia eventually got on there towards the end of the expedition, but had an extra month in quarantine to get on board that ship. So she had just come back from maternity leave. So again, there's a huge commitment there, a huge personal sacrifice many of our researchers make. But again, it's that emotional attachment that we have to this environment and our desire to preserve this environment that really motivates us to take some of these sacrifices. So it is important to recognise that this occurs across the board for our researchers. It does sound luxurious going to these wonderfully exotic places, but it also comes at some personal cost to us. Now, we're not just a group in New Zealand, we work very internationally. These big drilling projects are very expensive. We interact very closely with a whole range of international partners, particularly in the Ross Sea. We have the focus of the Koreans, the Italians, and the US, who all hold bases in the Ross Sea, and also China are also expressing interest in this region and building a base. So in this context, yes, we work very collaboratively, boots on the ground in Antarctica, doing the field work, but also working in that policy framework. And here we have Nick Gollage, who's one of several IPCC lead authors on the last climate change assessment report. So we're translating our science results into numbers that policymakers and decision makers can inform themselves around how to either mitigate against future climate change or adapt to it. And we also work very closely within a global coordinated group of the SCAR committee, which is the Scientific Committee on Antarctic Research, and that helps guide some of the research priorities for the global community as a whole. So we have strong leadership within that group. We're very strong in growing our own talent. We bring in lots of international students to New Zealand. We're recognised as a centre of excellence globally, and this attracts some of the best students in the world to our shores. But we also have a very strong emphasis in bringing New Zealanders through the program. So our research program, so these are postgraduates, sort of PhDs and masters, would probably be 50% international, 50% New Zealand, including taking down people that may not actually be working on things like rocks, but they might be climate modelers that are going down there to observe the scale of the processes that operate in Antarctica. It's very hard to make a connection to a place that you haven't actually physically seen. This is why it's important to take educators to Antarctica. We also take down our numerical modelers. We also take down our administrators to Antarctica, because we feel that when they are brought into what we do, then everyone works much more strongly to make sure that we are doing everything we can to help preserve this environment. And we work with our undergraduate students to sort of promote what the implications in New Zealand might be. Here we have a group of undergraduate students looking at rocks in New Zealand that are records of past sea level change associated with the ice sheets coming and going, melting and advancing over natural ice age cycles, and resulting in sea level cycles that are 50 to 60 metres amplitude. So our history has always been built around this geological program. Peter Barrett was a geologist, as I said, on Gondwana geology. Tim Naish was a geological sedimentologist. I'm a sedimentologist. We made our living looking at rocks and sediment that have been pushed off the continent by the ice sheets and dumped into the ocean offshore. And those sediments provide a record of how those ice sheets have changed. Are they there? If they're advancing, they're bulldozing and pushing sediment into the ocean. And as they retreat, they move away, there's no sediment put into the ocean, and we see marine algae settle to the sea floor. So we can see natural cycles of advance and retreat. And we've been doing that for well over 50 years in Antarctica, with varying levels of success. We started off with 50 metres in 1975, drilling through sea ice, then collecting sediment from the sea floor. But by the early 2000s, the end of the 90s, we're getting almost a kilometre of sediment out of these geological drill cores at the bottom of the ocean underneath the floating ice shelves. And this culminated in the mid-2000s with the Angel program, which is a very high profile drilling program, where we drilled through the Ross ice shelf. We're not collecting the ice, we're just drilling a hole through there. We lower a pipe to the sea floor, and then we put a drill pipe down to the sea floor and we start collecting sediments. 9 metres at a time, we bring it up to the surface, we look at that 9 metres, we lower another core down and we drill down another 9 metres. So it takes several months to collect over a kilometre of sediment from the sea floor, and over that time period, that ice shelf is actually moving. It's floating into the ocean, so it moves at half a metre a day and our pipe bends. So we only get a couple of months window before that pipe gets too bendy that we can no longer pull those 9 metre lengths of core up. But what you can see on the seafloor is you can see these repetitive cycles. You can see these yellow-coloured sediments, these grey-coloured sediments, and these brown-coloured sediments. And the brown-coloured sediments are sands and gravels and muds, and the ice sheets are just bulldozing anything into the ocean at once. So it's coarse-grained sediment. As it retreats, there's less energy. There's no longer that bulldozer, so it just becomes muds that are washing on the currents. And as the ice shelf collapses, we start seeing these yellow sediments, which are the algae that live in the ocean surface, die, settle to the sea floor, and preserve a record of an ice sheet collapse event, but also what the conditions of those waters were. So here is a stratigraph, what we call a stratigraphic column, and it's just a cartoon picture of what a drill core looks like over here, 150 metres to 500 metres below the sea floor. The yellow intervals are these intervals where we draw in a colour that represents one of those marine algae layers. So here we have almost 80 metres thick interval of algae. We can look at microscopes of these algae and map that these are what we call diatoms. These algae live in the oceans today. We know that they live in the oceans in waters that are intolerant of sea ice. So we can actually map how warm the waters are, how much sea ice is around. And so we could say that during these collapse events of the ice sheets 2.5 million years ago, waters were only 1 to 2 degrees warmer, and we're having West Antarctic ice sheet collapse. So this was a single point around Antarctica. It was just underneath the Ross Ice Shelf, which is in about where this location where my mouse is here. Okay, the ice sheet's gone there. How do we know the whole ice sheet's gone? Well, we actually then use this to calibrate a computer model. We recreate all the physics we know about an ice sheet, and we put it into a computer model, and we turn up the climate dial 1 to 2 degrees, 3 degrees in some scenarios, and we see how much ice are we losing in these geological periods in the past. Then we go and look at the future projection of climate change and run that same model under those conditions. And we see, would we see what's the rate of change? So we know 3 million years ago, for example, we lost almost 20 meters of ice from Antarctica, but it might have taken 5,000 years to do that. When we run these forward over hundreds of years, we can now see how much of that, in this case 10 meters in this model, how much of that is actually going to happen in the next 100 years. So that's what we do. We also do ice coring. I'm not going to talk too much about that, but that captures a physical record of atmospheric conditions in Antarctica over, potentially over the last million years. So these ice cores compact snow on the surface of the ice sheet, and then it eventually turns into ice, and it traps bubbles in it. And those bubbles contain a record of the atmosphere. We can actually measure how much CO2 is in the atmosphere, what the temperature is, and then we can actually, again, use that to compare to ice sheet models and climate models. So here is our expansion plan. So we actually run a national modelling hub here where we work with government agencies. We work directly with the research institutes that are funded directly out of government funding. So here we're hosting researchers from 3 different institutes, and they're all working on different components of the Earth system. So there's people that work on an ice sheet, there's people that work on the ocean modelling, and there's people that work on the biological modelling. So if you melt an ice sheet, yes, it'll raise sea level, that's the obvious one, but also change the way the water structures occur and how much nutrients are in the water, and that's going to affect the biology. So it's a whole system, and the biology itself is going to affect whether or not that's absorbing carbon dioxide or expelling it, the same way a tree would. If you grow trees, they absorb carbon out of the atmosphere. Marine algae do the same, they also photosynthesize. And so it's a very important component of the system, and it's all integrated. We don't call it the global climate system, we call it the global Earth system, because that connection to biology and climate is a critical part of it. And so here you can see what we're doing is we're actually saying, well, in 2100, under an extreme climate scenario of 8.5, this is almost business as usual. We're looking at, out of Antarctica, an upper limit of 0.4 meters by the end of the century in this particular ice sheet model. Now that's on top of the 0.5 meter that's already coming out of Greenland and thermal expansion of the ocean just from the physical warming of the ocean. So this is on top of many other estimates of sea level rise. So that's how we're working. You can see over 5,000 years, 3,000 years, you're ending up losing up to 10 meters. So this gets to that question, the geological records might see something like this, but these ice sheet models then can tell us how quickly did we get there. And that's what the societally relevant part of this is. And I'll just finish up that we talk about global sea level rise, but global sea level rise is not the same as regional sea level rise. It really depends on where these ice sheet melts are coming from. If it comes from Greenland, because there's a big gravitational attraction mass in Greenland, if you remove that ice sheet, the waters don't push up against it. So sea level is not a uniform bathtub. It affects globally, it can vary quite significantly depending on how much mass is next to that body of water. So if Greenland melts, rather perversely, sea level actually goes down right next to Antarctica, but it increases more dramatically elsewhere on the planet. So we try to understand that in this regional sea level rise change. We have the New Zealand Sea Rise Program that also looks at the added complication that we have a tectonically active country, and so earthquakes make the land go up and down. How do you factor that in, part of the country going down as well as from earthquakes, as well as sea level going up from sea level rise from Antarctica? Then you have a much more amplified sea level response in some parts of the country compared to others. So we have very applied government funded programs to actually understand what are the impacts on coastal communities in New Zealand. And we also look at our own glaciers in New Zealand. They are rapidly retreating. They will probably be gone by the end of the century, most of them. And that has significant implications for our agricultural systems, our horticultural systems, as well as our tourist industry as well, which are really dependent on these really iconic glaciers in New Zealand. Are really a canary in the gold mine for understanding that the implications of much broader climate change impacts on New Zealand. So I'll finish there.
Thank you so much, Rob. So much good information. What a wonderful overview of what the ARC is all about and some of its history. And I thank you for spending time with me today.
You're welcome.
Okay, bye-bye.
Bye.
Okay, so that concludes this session in the 24-hour share-a-thon. And we're going to prep for the next one. Does anybody have any questions before we go on Rob or Tim's presentation? Questions or comments? Okay, I just want to see what's in the chat box. Okay. Okay. Then we're looking to hand this over